Hello students, this video narration of a PowerPoint is intended to give you some background information that will help you better understand the little bit of readings from Copernicus and then the substantial reading from Galileo. So what this matter covers is sort of one of the most significant occurrences of a sort of antagonistic relationship between science and religion. We had already seen in De Rerum Natura that Lucretius has no qualms whatsoever of saying religion is very problematic and is going to interfere with your ability to understand nature. When we get to Galileo in the 17th century, the matter is a little more, it's complicated. We're going to see more situations where there is an antagonistic relationship between science and religion, but that is not always the case. If we think about the beginnings of astronomy, who were the people who made the star maps? These were Babylonian astronomers who were what they often described as scribe priests. These were people who were interested in viewing the heavens as a way to sort of predict the future for planting crops and also to understand their relationship to the divinity. So an awful lot of science was originally done by people who might be well described as priests. So if we start with the title slide says Galileo affair, we got the scientific angle and the church religious angle. So these are two things that are going to be included in this PowerPoint. So one we see is the Aristotelian model of the universe from around 350 BCE. And so it had certain characteristics. That the Earth is in the middle. The sun moves, so it is heliokinetic. And the Earth does not move. It is geostationary. We then get to the Ptolemaic model. So Ptolemy is a Greek Egyptian. So if you remember the map that showed the influence of the ancient Greeks, it was not limited to Greece, but went all over the Mediterranean. And so that included the area that becomes Egypt. So in Egypt, there are Egyptians who are ruling the place, but there are Greek-speaking scholars. The Library of Alexandria is filled with Greek texts. So this points to the influence of ancient Greece throughout the Mediterranean. And so Ptolemy takes Aristotle's model, which doesn't quite fit naked eye observations because sometimes planets appear to move backwards. And so what he does is he makes some adjustments to it. So in the Ptolemaic model, Earth is the unmoving center of the universe. All heavenly bodies undergo circular motion around the Earth, and all heavenly bodies are made of perfect, unchanging substance that's not found on Earth. So these are a couple features of the model that we're going to see end up being problematic when we get to Galileo's observations. So then we have deference and epicycle. So this is an effort to save the Ptolemaic model. So in order to, how do you explain that if things are going around Earth in perfect circles, sometimes they appear to be going backwards? Well, what you do is you say, well, they're going around perfect circles on perfect circles. So the next slide shows you where you've got an observable planet in position 1, and it's going counterclockwise around us on Earth. And then when it gets to position 2, it then seems to go backwards to position 3 before then reappearing in position 4. And so when we talk about Mercury retrograde, that's what's describing this idea that Mercury, you're watching it go around and then suddenly it seems to reverse direction and then it continues, etc. Well, that's what you would see if you had a circular thing going around a circular thing. You would get these little loopy-loops. So we then come to Nicholas Copernicus. He's a Polish polymath. He's an astronomer. He's a mathematician. He's a cleric. He's a lawyer. He's a diplomat. He's everything under the sun. He's in 1473, 1543. So this is about 100 years before Galileo. And he's an amateur astronomer doing naked eye observation. Why? They don't yet have telescopes. So he developed or adapted a heliocentric model that simplified the math. So because he was a really good mathematician, and because he understood that the epicycles and deference that they had put into the model to save the appearances were just a mess. They were not at all elegant. He says, if we put the sun in the middle and have the planets go around it, everything is much simpler. So in his model, it is revolutionary, two revolutionary points. One is heliocentrism versus geocentrism, and the next geokineticism versus a stationary Earth. The problem, naked eye observation can't distinguish Ptolemaic and Copernican models. So you've got these two models, you look up in the sky, either one can be used to explain what you're seeing, and it was only sort of a mathematician who was really dedicated to elegant solutions would say the Ptolemaic model is much better, because the Copernican model is much better. But biblical authority dictated the supremacy of the Ptolemaic model. So here's a couple places where the Bible says, on this day the Lord gave the Amorites over to Israel. Joshua said to the Lord in the presence of Israel, O sun, stand still over Gibeon, O moon, over the valley of Ajalon. So the sun stood still and the moon stopped till the nation avenged itself on its enemies, as is written in the book of Joshua. The sun stopped in the middle of the sky and delayed going down about a full day. Another place where we find evidence of a moving sun in Ecclesiastes, the sun also ariseth, and the sun goeth down, and hasteth to the place where he arose. Okay, so this points to a couple of ways in which our everyday language is supporting a problematic model. We say sunrise, we say sunset, we say the sun is coming up, the sun is going down. We should say the horizon is going down when the sun appears to be coming up. The horizon is going up when the sun appears to be going down. So our language sort of supports one model of the universe, the Ptolemaic model, and we use it every day. And so it makes our embrace of the superior, mathematically superior model and accuracy model is at odds with everyday language. We now turn to Galileo Galilei, Italian natural philosopher, 1564-1642, about 100 years after Copernicus. So now he says, why don't we rely on observation and rational thought? Okay? So he's got a new telescope. He turns the telescope towards the heavens. Several observations that are inconsistent with the Ptolemaic model. Venus has phases. Okay, this doesn't work with the Ptolemaic model. Jupiter has moons. This doesn't work with the idea that everything's going around the Earth. Heavenly bodies are not perfect. We've got sunspots. We've got roughness of lunar surface. This is problematic. Also, theoretical challenges to Ptolemy. The hypothesized that tides are caused by movement of the Earth, and hypotheses concerning gravity. So Galileo got a couple of things wrong, but he got most of his celestial observations quite right. So, Galileo's impact. Copernicus published in 1542. The church condemned the Copernican system in 1616. Why did they do that? That's a complicated story we'll get to in a later class. One of the reasons is Galileo published some books and essays in Italian rather than Latin, and this is a problem for the church. And then why else? The why else would be the idea that significant turmoil extending into the 17th century. The Protestant Reformation challenges the church authority with respect to biblical interpretation. So suddenly, anybody who is questioning the interpretation of the Bible, this is seriously problematic, and it's a good way to get put to death. The problem of atheism. Many people are turning away from biblical authority. So if atheism is this rising problem, anybody who questions any part of the Bible is a troublemaker. Why might Galileo be a problem? He's questioned, he's admonished, he's re-questioned, he's punished by the Inquisition. So there's your sort of a brief historical background. We're going to go into more detail on technologies and their impact in that, but that should help you get into the Copernican and Galilean readings. There you go.